by lining them up to this, we're able to find all the parts to it. You can find your center, and I gave you a whole page of notes to follow this with. Do you have to know what these exactly look like? No, but know that every time in an ellipse you have a focus point in a parabola, right? Whether it's in here or whether it's out here, you have a focus point. You have two focus points, foci points in an ellipse. And technically what that does is, if you make any lines to your circle and to the other one, those distances are always the same. The sum of those distances are constant. Do we do that part of the ellipse? No, we don't even do that part, but that's what makes it an ellipse. It doesn't have one center, it has two foci points. So even though we find the center here, we're going to use these foci points to make this, to make this happen. But we don't even do this part. We just lay out the center, we find the foci, and we graph our ellipse. And it's kind of easy. We do the distance of one, the distance of the other, so we know which one's the major axis, and you'll see this happen in a minute. So we have two types here. We have a horizontal major axis, where your ellipse is going to be long horizontally. And we have a vertical major axis, where your ellipse is going to be long vertically. Okay? Now, A and B will change. A is going to be the larger, the major axis. If the larger number, say this number is 16 and this is 9. This is 16 and this is 9. The one under the larger number is the major axis. This is, you don't have to sign me just take one of these as much. This is an add. So it doesn't matter what order you add in. It doesn't matter who comes first, the X or the Y. What matters is who's the major axis. So for us to tell, the easiest way is the larger number on the bottom is the major axis. And that's how we're going to do this. The larger number gets the A, the smaller number gets the B. And obviously we're going to have to take the square root of these guys because they're squared. This is where your center comes from. This is where your center comes from, and we're going to make your foci points in here as well. Your foci points we do with the C, and the C comes from here. This part is probably something you have never seen, and we use this to find C. Excuse me. C is equal to A squared minus B squared. That's a little different than your Pythagorean theorem, but it's going to work for us to find your C value. So we're going to find your center, we're going to find your major axis, we're going to find your minor axis. Your endpoints that sit on the major axis are called the vertices. Your points that sit on a minor axis are called the co-vertices. We have to find those points in order to graph your ellipse. We sketch. I shouldn't say graph, we sketch. So we're going to sketch the center. We're going to find the distance between here and the distance between here. And we're going to sketch that. Major distance, minor distance, depending on which one is your major vertices. Okay? And the distance and your foci come equal distance on both sides of your center. Okay? God bless. It looks worse than it really is. Just grab a homework sheet if you don't mind. Grab your class sheet and your homework sheet. Alright. We're going to make this simple at first. We're going to start like this and do a simple one. I think this might even be the first one of your homework. Is this the first one of your homework page?
The 16 and 25 are started.
The 16 and 25 are started. Okay. So it's very similar to the first one of your homework. Alright, now, we're going to start real basic. we're going to say, what's the center of this ellipse? First of all, let me step one back. The way we tell that it's an ellipse is we have an x squared and a y squared and a plus in the middle, and these are not the same. If these were the same, and I multiplied everything by 9, this would be a circle, okay, which is a special ellipse. An ellipse can be a circle. An ellipse is a special circle. Just grab one of these in there. So that's how we're going to tell the difference. They're both squared. When we do a hyperbola, the hyperbola is going to have the minus in the middle. So they almost look like a circle because an ellipse is kind of like an elongated circle. And we're going to say, okay, what's the center? What's your H and K? 0, 0. Okay. Which one is larger, 16 or 25? What's the larger number? 25. This becomes a squared. This becomes b squared. This guy is our major axis. Because it's on the y, it means it's going to look like this. Okay, so we're going to start with the sketch. We have a 0, 0 center. We're going to say b squared is equal to 16. So what is b? 4. A squared is equal to 25. So what is a? 5. We've got to find c squared. So we're going to take 25, and we get a lot of radicals in this because we're square rooting a lot. So c squared is equal to 9. So what is c equal to? 3. So here's the easiest way to sketch your ellipse. You're going to go up 5. You're going to go down 5. You're going to go over 4, and you're going to make your ellipse. I'm horrible at drawing circles and ellipses. It's going to look more, this is pretty bad. It's going to, God bless you. It's going to go up 5 and down 5 and over 4. I'm going to make it look a little bit better. There's your ellipse. Better? Yeah. The 3, not yet. We're about to. Boys in the back, ready? Okay. So we found your center to be here at 0, 0. Now your foci is where the C comes in. The foci says go up 3, go down 3. These are your foci points. That's where the C comes in. Now technically, on an ellipse, whenever I take the sum of any of these parts, they will be constant. Do we do that here? No, we just sketch an ellipse to see what it looks like. We find your vertices, your major axis. Start like this. Your major axis is your y-axis because that's the larger number. Even if you come down here, put a little asterisk next to your larger one. That's going to be where your vertices are. So your vertices are 0, 5, and make sure you put these in the right order, and 0, negative 5. Okay. Your minor axis is the x-axis, and these are called co-vertices. Kind of like a pilot and a co-pilot. The pilot's the main guy, the co-pilot, not that he's a minor person, but he's that's the minor part. So this is going to go out 4, 0 and negative 4, 0. And the only other thing we need to know is your foci. Your foci always go on your major axis. So we're going to go up 3 and down 3. And there's your foci. Foci because we have 2. Focus, for 1, foci for 2.
Should we put it like in all together?
Yeah, however you get to set this up, however you want to set this up is fine. Okay, again, we have a formula from your formula page for foci. I find it easier if you just look at your sketch, take your center, like we did with your vertex point, and figure out where your focus was. Do the same thing with your center. Figure out your major versus your minor. Put it on your major axis, and just kind of count off your center. Again, you're making a sketch. We're not using graph paper. Nothing has to be exact on this, but it has to be within reason. Okay, so you've got a couple of things. This is important. Every time you do this, lay out ABC. That's going to help you graph. Put a little asterisk next to your major. The major is the larger number in the denominator. Find your vertices and your co-vertices and your foci points. Good, Anthony? Okay, we're good? All right, let's try another one. I think I kind of kept it. Oh, it's 51. All right, so tell me what your major vertice, what your major axis is. Yes, so this is A squared, this is B squared. Start like this. What's A? What's B? Now how do I find C? Good. A squared minus B squared. 25 minus 16. And what's C? 3. Okay? So, asterisk next to your major axis. So your major axis is your x. It's going to look like this. It's just oblong along the x-axis instead of the y-axis this time. What's your center? 1, negative 3. Good. Works just like a parabola. The one with the x is the h. That one comes first. Okay, so we're going to start. We're going to sketch this. Not a lot to do on an ellipse right now. In the next 5 minutes, we're going to complete the square. It gives us a little bit more to do. But remember, it's kind of like the basic setup of a circle. The center, this is always equal to 1. We want this always equal to 1. We want the add, and we want to see that the two denominators are different. And we always want to set them equal to 1. The ellipse and the hyperbola have to be equal to 1. So we start with your center. 1, negative 3. Now, what I like to do is go like this. I like to make a translated origin. You kind of translated it off because this is going to help you figure out which way you're going. So this is 1, negative 3. You're going, A is your major axis, and this is your x-axis. So we're going 5 over. 5 over here, 5 over here. This is your vertex point. When I go horizontally, which one is going to change, the x or the y? X. So if I take 1, negative 3, if I take 1 and I add 5, what's my vertex? My vertex going to be? 6, negative 3. If I take 1 and I subtract 5, what am I at over here? Negative 4, negative 3. Okay. Then I'm going up and down. I'm going up and down B, 4. So I go up, co-verticing, down, co-verticing. So up and down changes the y, moves the y-axis. So what's this point going to be up here? I need to add 4 to negative 3. 1, 1. And this point down here, 1, negative 7. Just like you do your parabola. You can go by your formula on your formula sheets if you want to. I know some of you like the formulas. I saw if you use the formulas. But you still have to figure out which way you're going, whether you're adding to the h or you're adding to the k. So we've got your vertices at negative 4, negative 3, and that's 6, negative 3. We have your co-vertices at 1, 1, and 1, negative 7. And now we're going to find your foci points. Your foci moves C, and it's always inside your ellipse. So, C, we're going to add 3, and we're going to go which way? Up and down or sideways? Sideways. We're going to your major axis. So if I add 3 to 1, what do I get? 4, negative 3. If I subtract 3 from 1, what do I get? I know this is off a little bit, but that's okay. Negative 2, negative 3. So foci at 4, negative 3, and 2, negative 1. Nope, negative 2, negative 1, negative 3. Negative 2, negative 3. So here's your ellipse. I stink at drawing these. But it's kind of more oblong here, along your x-axis. Everybody okay with that? That's all we have to do. Now, hard part is when it looks like this. That's the hard part. So what do you think we have to do? Complete the square. We're going to have to complete the square. Weren't those things like squares, like your parabolas were? Weren't those little two pieces of squares? Now instead of one square, this is how we tell this is an ellipse. When I give you one of these, this is how you're going to tell. You have an x squared and a y squared. This could be a circle, but it has, or it could be could be an ellipse or a hyperbola, but it has a plus in between. So far, if we kept everything to one side, they would stay plus. These are different, and so this is how we're going to complete the square. This is going to make our center, and 8, we're going to move to the other side, and this side has a different coefficient. So we know this is going to be an ellipse. So put in order, put these together, put your x's together, God bless you, leave a space. Put your y's together, leave a space. Move the 8 to the other side. And leave 2 spaces. If we complete the square twice, we have to leave 2 spaces. Now, when you do this, your coefficient has to be 1, and it has to be a positive 1. So I can't use the 4. So out of this little group, I'm going to factor out a 4. We're going to x squared. No, we're going to factor it out because x has to be 1. Its coefficient has to be 1 positive. So we factored out the 4. We're still going to leave a space. This is going to stay. This guy's a 1. He's going to stay. So now, what's half of negative 2? Keep this 4 down here. What's negative 1 squared? 1. But to bring this out of this parenthesis, I have to multiply by 4. So what's 4 times 1? 4. That's what goes over here. He's stuck in that parentheses. If I need to get him out, I need to multiply him by 4. Technically, this is 4x squared minus 8x plus 4. That's what makes my perfect square. Then I do this guy. What's half of 4? What's 2 squared? Okay, I add 4 here, I add 4 here. So this gives me 16. We're almost there. My ellipse has to be set equal to 1. So I got to get this guy to be 1. Divide everybody by 16. Alright, be right back with you here. So divide by 16. Now, 4 goes into 16 how many times? 4. These coefficients up here have to be a 1. Here's your equation. God bless you. Here's your equation of your ellipse. We have to do 2 complete the squares to get it into this format. What's your center? Good. Which one is your major axis? Y. Good. So what's A? 4. What's B? Remember, if it's squared on top, it's squared on the bottom. That's a good way to remember that that's the square.
2.
And C is, be careful of C. It's A squared minus B squared. So it's 16 minus 4 is 12. Gets a radical.
Right.
So we're going to take out a 4. Good. So it's your radical 3. We know it's going to be a major axis on your x-axis, we said? No, your y-axis. Your y-axis. Alright, so let's start. Let's get the sketch. Start with your center. 1, negative 2. Here's your center. Make a little translated axis. It's the easiest way to do this. Because it's real kind of hard to visualize off of a point. Just take a bunch of little dotted lines. So now, we said y-axis is where your vertices are going to go. It's going to go up 4. So if I go up, which one am I changing, the x or the y? The y. So if I go up 4, what's this point going to be? 1, 1, 2. Good. If I go down 4, what's this point going to be? Good. 1, negative 6. Everybody good with that? Same thing we did with your parabola. Okay. All right. Now, on your x-axis, we're going over 2. So if I go over 2 over here, I'm moving the x. I'm at 1. I need to subtract 2. What will my point be? Negative 1, negative 2. Go the opposite way. I'm going to add 2. What's my point going to be? I'm adding 2 to the 1. 3, negative 2. Here's my ellipse. Okay, good so far? Vertices, 1, 2, 1, negative 6. Co-vertices, negative 1, negative 2, 3, negative 2. Once you write this out, you kind of should see that your 1's line up, your negative 2's line up. Now, my foci are going to be on which axis? My x or my y? On your y. Good. They're going to come up 2 radical 3, and 2 radical 3 is about the 2 times 2 almost, a little bit, almost like 4, a little bit less than 4, so they'll be about here. Now because they're a radical, we really can't add a radical to a rational number, so we're changing your y, so your foci are going to be at 1, negative 2, plus or minus 2 radical 3. You have to make life simple. Moving up and down, and we can't add your radical to your rational, so we just leave it like that. Yep, that's both of them. That's all we have to do to it. We good with this? Alright, let's see if we can complete the square on one more. Because that's the hardest part, completing the square.
Do we lose points if we don't have a circle?
You don't have another one?
No.
Do we lose point? You've got to sketch it in.
Too good.
tell you what, I'll do one from your homework. One big one from your homework. 15. Okay, everybody take out your homework. Let's do number 15. Oh, what is going on with my board? This is really important, guys. Group the X's together. You're going to have to factor out and group the Y's together. Put the 36 on the other side. Don't worry about the negative. We'll figure out the negative in a little while. Out of this group, this has that your coefficients, whenever you go to complete the square, has to be a positive 1. So we're going to factor a 9 out. And we did this way back like September, October. And leave a space. We factored out a 9 out of these two. Just those two terms. What are we going to factor out of these? 4. This coefficient of y has to be 1. And leave a space. 2 spaces because we did this twice. So for this guy, what's half of 4? 2. And 2 squared? 4. Now to get it out of this parentheses, distribute the 9. What is 9 times 4? 36. That goes here, not on this side. You don't put it on your left side because that's where you completed your square. What's half of negative 6? Negative 3. We've got to bring down the 9. What's 3 squared? Bring this out again. What's 9 times 4? 36. Bring your 4 down. And these 36's come out. 36. Okay, make sure you factor it out. Make sure you take your middle term, take half. Make sure you distribute it back out. And then don't forget to bring these down. Questions just on that part. Right, we need this set equal to 1. And you saw that we had a fraction in this, so divide everybody by 36. This is where you get the ellipse, not a circle. The 9 comes in. Well, guys, let me just finish this so you can finish this for homework. The 4 comes into here. Now you're okay to do your homework? Which axis is the major axis? The Y. Right? So you've got those for homework.